Hi everyone, and welcome to this series of lessons on chromatography. There's 3 lessons in the series and they are designed to go alongside your project and support you in doing that. Now before we begin, can you please make sure that you've got a pen or a pencil and some paper to write on. If you haven't got that, pause this now and go and collect those. And when you're ready, let's get started with lesson 1, running a chromatogram. Alright, to warm our brains up, let's start with a little retrieval exercise. So based on what you know from your lessons so far this year, can you write down on your paper definitions for an element, a compound and a mixture? Please do make sure you write these down, do not do them in your head. So pause this now and give yourself a few minutes to get that done. Okay, then let's see how you did. So an element is a substance made up of only one type of atom. Okay, it's important that you've written down one type of atom. A compound is a substance made up of more than one type of atom, and those are chemically joined together, so they have to be held together by a bond. Now a mixture is a substance that's made up of more than one type of atom or compound, but they are not chemically joined together. So we get different types of mixtures. You might get a mixture that's made up of 2 different types of atom, or you might get a mixture that's made up of 2 different types of compound, or you might get a mixture that's made up of atoms and compounds, but they mustn't be chemically joined together. So what's all that got to do with chromatography? Well, chromatography is a method that we can use to separate out mixtures. Now because mixtures aren't chemically joined together, we can separate them out based on their physical properties, and in terms of chromatography what we're looking at is how soluble the different parts of the mixture are, and we can use that to separate them out. So how do we go about that? Well, this would be a lot easier if you were sitting in front of me and I could show this to you. Trying to imagine this in your head is quite difficult, so I've included the link to one of the YouTube videos from your project at the top of this slide. Pause this now and watch that video from start to finish and you'll see a demonstration of how it's carried out. Once you've done that, come back and we will talk it through a little bit. Okay, so in chromatography you need to start with a piece of chromatography paper. And on the bottom of that paper, about 1 centimetre up from the bottom, you're going to draw a pencil line across the bottom using a ruler. What you're then going to do is you're going to take a sample of whatever it is that you're trying to separate out. So it might be ink from pens, or it might be food colorants, or any number of things, and you put a dot of that sample on the start line. Okay, now what you want to do is you want to try and get quite a concentrated spot. So you don't want a really massive spot because that'll spread out too much, but you want it quite concentrated. So if you're doing it with, for example, a pen, then the best way to do it is to do a little dot very quickly and lift your pen up and then give it a couple of seconds to dry, and then on the same spot put the pen down again and then a couple of seconds to dry, and repeat that a few times. Then you get a nice concentrated spot, but one that hasn't completely spread out. So the next step is you're going to take your piece of paper with your spot on and you're going to put it into a beaker. Now in the bottom of that beaker you're going to have a very, very small amount of a solvent. Now what the solvent's going to do is it's going to move up the paper and pick up the sample that you've got and carry it up the paper. So you need to choose a solvent that the spot is actually soluble in. Okay, that's important. Now you only want a very tiny amount of your solvent in the bottom because you don't want the solvent to go over the start line. If it does, then what's going to happen is the ink will just dissolve in the solvent and float away from the paper, and then the water will still rise up the paper, but it won't carry the ink and the whole thing will be a waste of time. So you just want a very small amount, and it needs to be underneath the start line. So then you're going to give it a few minutes and you're not going to touch it at all. Okay, you don't want to disturb it. You want the water to rise really nice and evenly, and it'll pick up the sample, the spot, and it'll carry it up the paper. And if that spot is made up of more than one type of thing, then you might get a few different spots rising up the paper. If it's made of only one thing, so if it's a pure sample, then you'll only get one spot at the end. Now when the solvent gets close to the top of the paper, again about 1 centimetre from the top is a good place to start, you're going to take it out and you're going to draw a pencil line across where the solvent reached. Now that pencil line is really important because your solvent's going to dry and you're not going to be able to see it, so you need that line there so you can see exactly where it rose to, and that line is called your solvent front. Now before we go any further, I want to jump back to the very beginning, the first step where you drew your line across the bottom in pencil. It's really important that that line's in pencil and not in ink, because if it's in ink and the ink happens to be soluble in your solvent, then the line will rise up and you'll not be able to distinguish your sample that you're trying to test from the start line. If you draw it in pencil though, that pencil won't move, so the start line must be in pencil. Okay, so let's just double check a few keywords. So solute, what is a solute? Well, the solute is the substance that has dissolved. So in the example that I gave you before, it's the ink. Okay, that's the solute. The solvent is the chemical that dissolves the solute. So in this case, it would probably be water. Your mobile phase and your stationary phase, these are two key terms that you need to get right the right way around. The mobile phase is the part that moves. Okay, so it's the liquid that carries the component, so the water. And the stationary phase is the part that doesn't move at all, so that would be the paper. So let's see how much you've absorbed. You can have a go at some exam questions. This one here is worth 2 marks, so pause this for 2 minutes and write down your answers and then come back and we'll go through the solution. Okay, so let's have a look at the answer to question 1. So the question is, a student investigated a food colouring using paper chromatography. This is the method used. 1. Put a spot of food colouring X on the start line. 2. Put spots of 3 separate dyes A, B and C on the start line. 3. Place the bottom of the paper in water and leave it for several minutes. So figure 1 shows the apparatus that the student used. So you've got the beaker, you've got a lid on that beaker, you've got some water in the bottom, and you've got a start line drawn in ink. And the question is, give 2 mistakes the student made in setting up the experiment. So tick 2 boxes. So the first option is the lid was on the beaker. Well, I didn't mention a lid before, but the lid is actually quite important, sometimes depending on what kind of solvent that you've got. Some solvents evaporate really easily into the air, and so the lid is there to stop them from escaping. Okay, so the lid wouldn't affect the chromatography, it would actually be a good thing, so it's not that one. Paper didn't touch the bottom of the beaker, that's not a problem, that's absolutely fine as long as the paper is touching the water. It doesn't need to touch the bottom of the beaker, so it's not that one. Spots are too small. No, that wouldn't matter. It would just mean that the spots, when they did rise up, would be quite small themselves. Start line drawn in ink. Now remember what we said, that is a problem because the ink will dissolve in the water and it'll also rise up the paper and you won't be able to tell your results. And then the water level was above the spots. Again, that's a huge issue because it would mean that the spots would just dissolve in the water and float away from the paper entirely. So it was the bottom 2, start line drawn in ink, and the water level was above the spots. Let's have a look at question 2. So this one's worth 4 marks, a little bit more writing to do in this one. So again, pause this, read this thoroughly, have a go, write down your answers, come back and we'll see how you've done. Alright, exam question 2. So let's have a look. We've got a student investigated the colours in 3 different flowers, A, B and C. The colours are soluble in ethanol but are insoluble in water. This is the method used. So 1, crush flower A. 2, add ethanol to flower A. 3, filter the mixture. 4, put spots of the coloured filtrate onto the chromatography paper. Step 5, repeat steps 1 to 4 with flowers B and C. And then we've got figure 1 showing us the apparatus used. The question is, the student made 2 mistakes in setting up the apparatus. Give 1 problem caused by each mistake. So you're going to get a mark for mistake number 1 and then a mark for the problem caused, a mark for mistake number 2 and a mark for that problem caused. So let's start with mistake number 1. Well, the start line is drawn in ink again. So as we've seen before, the problem that's going to cause is the ink is going to dissolve and it's going to run in the solvent, so it's going to get carried up the paper and that's going to interfere. And then mistake number 2, well, for this is quite a sneaky one. You have to look at line 2 of the original question. So if we go back up and look, the colours are soluble in ethanol but they're insoluble in water. We'll look at the solvent that they've chosen. In figure 1 it shows you that the solvent is water. So if the colours are insoluble in water, then they're just not going to dissolve and they're not going to move from the start positions at all. So mistake number 2 is that we've used water as a solvent, and the issue that it's going to cause is that the colours won't dissolve and move up the paper. Okay, that's for mark number 4. So what you'd need to do to make this work is you need to swap out your solvent for ethanol. Okay, so exam question 3 is worth 2 marks, and then exam question 4 is also worth 2 marks. Try these two together because they're two parts of the same question, and then come back and we'll go through the answers. Okay, so let's start with question 3. Question 3 was, a student investigated the colours in 3 different flowers A, B and C using paper chromatography. The colours are soluble in ethanol but are insoluble in water. This is the method used. Place ethanol in a beaker, add the flour, stir until the colours dissolve in the ethanol, filter the mixture, put spots of the coloured filtrate on the chromatography paper. The filtrate was very pale coloured solution. How could the student obtain a darker coloured solution? So this question started out really similar to the previous one, but it's actually gone in a different direction. What it's asking you now is, if you've got a very pale solution, that colour, the spots will be difficult to see. So how could you get a darker coloured solution? Well, if we have a look at the method, all they did was place the flour in the ethanol and then let the colours come out until there was a little bit of colour in the ethanol. If you really wanted to get the maximum amount of colour out of that flour, then you really should crush it. So the first one, crush the flour. Next option, filter the mixture 3 times. Well, that won't affect the darkness of the colour of the solution. All filtration does, remember, is remove the solid bits of flour from the solution. So filtering it more than once won't help. Use a larger beaker, that's not going to help either. Use more ethanol, nope, that won't help. In fact, that will probably make the colour even lighter because you'll have the same amount of dye in a larger amount of ethanol, so it'll appear even lighter. And then the last option, use more flowers. And again, if you use more flowers, that's going to give you more dye into the ethanol, so that's going to give you a darker colour. So it's the first one and the last one. Crush the flour and use more flowers. And then question number 4. Figure 1 shows the apparatus used. What 2 mistakes did the student make in setting up the apparatus? We've seen this question very, very similar to this several times now. This is a really common question. So tick 2 boxes. Paper doesn't touch the beaker. Again, not a problem. Been through that before, that's absolutely fine. Start line is drawn in ink. That is an issue. We've gone over why that's an issue. Water levels below the start line. Well, that's exactly where it should be, so it's not that one. Use a lid on the beaker. Remember, we just said that all the lid does is prevent the solvent from evaporating, so that's actually a good thing. And then uses water as a solvent. Remember, go back to the beginning and it tells you the colours are soluble in ethanol but insoluble in water. So remember, if they're not soluble in water and water is your solvent, what's it going to do? Well, nothing. The spots are going to stay exactly where they are. They're not going to dissolve and they're not going to move up the paper. So the 2 mistakes that they made was the start line is drawn in ink and they've used water as the solvent. So the second one and the last one. Alright, so before we go, let's just do a quick keyword check. Again, pause this for as long as you need and do your best to write down a definition for solute, solvent, mobile phase and stationary phase. Okay, now you've had a chance to do that. Check your definitions against the ones that are given on the screen now. So solute is a substance that is dissolved. Solvent is a chemical that dissolves the solid or the substance. The mobile phase is the liquid or the gas that carries the components. So in our case, it's the liquid. And the stationary phase is the part of the equipment that doesn't move. So in our case, the paper. Alright, so we'll wrap it up there. Thank you very much. Have a look at lesson 2 and I'll see you next time.